Okay, so for example, we have carbon, one more carbon, one more carbon, one more carbon, double bond with another carbon, single bond with another carbon. Okay. For example, there is chlorine attached. There's a chlorine. For example, there we have CH3. For example, there we have CH3. There are a lot of, there are a lot of types of structure, but not every type is included in your syllabus. They will not give you more complicated structure. Means they will not give you any structure in which they will give you three methyl groups here, because that is more complicated and the rules are totally different. So they are not going to give you those type of structure in the in your exam. I mean, because I'm checking here, I have here a topical past paper here in front of me, so I'm just teaching you according to the past paper. So don't get confused by thinking about other structures. They will not give you that much difficult the structures. Now see, for example, so for example, we have one more. Let's make CH3 here instead of here. You can draw CH3 here. Now see, first, the molecular formula is really easy. You don't have to go in the detail of molecular formula. They will not ask you for the molecular formula of this type of compound. But yes, if you want to know the molecular formula, so definitely you have to make some bonds here, some hydrogen bond. Oh, no hydrogen, no hydrogen, no hydrogen, no hydrogen. Because this carbon is already making 4 bonds. This is already making 4 bonds. So there is no hydrogen, but yes, there 1 hydrogen. No, there will be 3 hydrogen. Yes, 1. And there will be second hydrogen upside and here and here. So you can see this is something like molecular formula. C1, 2, 3, 4, 5, 6. C6. You have to count red hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9. H9, CH3, 2, Cl. This is the molecular formula. You can write Cl before CH3, that's okay. So this is the molecular formula. What about a structural formula? I don't think so that a structure formula would be difficult for you. CH3, CH in bracket Cl, CH and inside the bracket CH3, then HC, not CH, because you have to show the double bonding. Then C in bracket CH3 and then CH3. Let me write it for you so that if you are making any mistakes, so you can correct it. Let's do it here. CH3. The first one. Second one, CH, and in bracket, you can write Cl. It's more good if you are writing these things in a bracket. Then let's move to the third one, C, H, and CH3. You don't have to write CH4. Keep in your mind, it will be methane. Chemistry is all about, you can say chemistry is all about the structures, organic chemistry. So if you're writing CH4 here, it is not considered correct. It means there is a methane in a compound. No. Okay, CH4, and then we have to move the fifth one. There is only CH, but you have to write HC so that you could show the double bond like this, then CH3 inside the bracket, and then there is CH3 outside the bracket. This CH3 inside the bracket is showing that this is a functional group. So this is the structural formula of the compound. Any confusion? Yes, Anna?
No.
Okay, now let's move to name. What will be the name? We have to discuss name also. Okay, so the name will be, how many carbons are there? 1, 2, 3, 4, 5, 6. 6 carbon means this is hexane, but this is not hexane, this is hexene. There is a double bond. Okay, so let's give number to the carbon first, then we can check first carbon, second carbon, third carbon, fourth carbon, fifth carbon, and sixth carbon. Okay, so now what you have to check, you can see that there are some chlorine, chloro group, the methyl group, and the double bond also. So let's write methyl and chlorine first. So at second and third, we have methyl. At 6, we have chloride. You have to go alphabetical. You cannot say that 2 methyl, 2 and 4 methyl, 6 chloro, methyl start from M, chloro start from C. So you have to go alphabetical for the functional groups. This is also a rule. You cannot learn the rules of IUPAC system. You can learn by the practice only. So you cannot write 2, 4 methyl, because methyl start from M. There is another functional group, which is chloro. It starts from C. C comes first. C comes before M. So you have to write chloro first. So C, it will be 6 chloro. Then you can write 2 and 4 methyl. And then we have the chain is having 6 carbon, and this is hexene. If you say 6 chloro 2 4 methyl hexene, or if you say, Miss, this is correct, so let me tell you one thing. If you say, Miss, I have 6 chloro 2 4 methyl hexene, so okay, I know, okay, at 6 carbon we have chlorine group, and at 2 4 we have methyl group, and this is hexene. But where is the double bond? Or there could be 2 double bond. You can see the name is not showing that how many bonds are there and how many hydrogens are there. There could be 2 double bond. There could be 3 double bond. Or if there is 1 double bond, so it could be with the second carbon. It could be in the middle of the chain. It could be at the end of the chain. How do we know that where is the double bond? You have to mention that thing. Where is the double bond? At the second carbon. You can see the double bond is there at the second carbon. So if you say, Miss, we can write 6 chloro 2 methyl 2 hexene. 2 hexene means you have 2 hexene. No. What do you have to do? Wait. We cannot edit it. Wait, let me write it here. Instead of hexene, because this is a mistake, because you have to show the double bonding. So instead of hexene, you have to say 6 chloro 2 4 methyl hexa 2 ene. There is no suffix prefix type things for the alkene, no? So you have to write like this, hexa 2 ene. This is hexene, but where is ene thing? What is ene? The double group. So ene is the suffix for the double bond, you can say. And you have to write the number before the suffix or the prefix. You can say that's what we are doing when we are naming the compound. So where is ene? You have to tell them. So hexa 2 ene. So what will be the name of the chain? 6 chloro 2 4 methyl hexa 2 ene. Is that clear, Zana?
Yes. Can it be 2 chloro 3 5 methyl hexa 3 ene?
Sorry, what's your question?
Can it be 2 chloro 3 5 methyl hexa 3 ene?
Okay. Let me wait. Let me change the question here. Wait, I'll make the changes. You have to tell me again what you are saying. Wait. So it should be hexene. Okay. So yes. Now tell me what is the first thing which you said?
2 chloro.
Wait, let me write it here. You said 2 chloro. Now you are giving me the name and we have to make a chain. Okay, 2 chloro, yes.
3 5 methyl.
3 5 methyl, and yes.
4 hexaene.
4 hexaene?
No, hexa 4 ene.
Yes, hexa 4 ene. Okay, now see. 2 chloro for now if you say, Miss, where we have to write 2 chloro. 2 chloro means there is chlorine at the second carbon. So second, now we are making we are making a chain now. So the second carbon could be, let me show with the red one. The second carbon should be this one, and the second carbon should be this one. So whenever you have a choice to make a structure, you always start from the left side. Oh, sorry, right side. This is a rule actually. We usually start from the right side. So this is first carbon. This is second carbon. This is third carbon. This is fourth carbon. This is fifth carbon. This is sixth carbon. Okay. So at second carbon, we have chloro, Cl. At 3,5, we have methyl. So at 3,5, you can write methyl upside or you can write methyl downside. Both are acceptable. CH3 and 5. At 5, we have methyl CH3. And hexa-4-ene means at fourth carbon, we have a double bond. First carbon, second carbon, third carbon, fourth carbon. So double bond is starting from the fourth carbon. This is the structure of 2-chloro-3,5-methyl hexa-4-ene. Yes. Any confusion?
No, it's clear to me now.
Okay. Okay. So let's draw the skeletal formula of the chain, which you told me. Let's focus this one because I have already removed the previous carbon chain. Okay, let's remove this one. Okay. Now you have to draw the skeletal formula. For a skeletal formula, we don't need naming. We need this structure. It is more good that for the skeletal formula, you are making a structure first, then you are converting it into the skeletal formula. Or when they are giving you the skeletal formula, because you can see your past paper, mostly they are giving you skeletal formula for the phenol, for the benzene. And that, I mean, this thing make your question more difficult. So what you have to do, instead of solving directly, try to convert your skeletal formula into displayed formula, this one. You can do this thing in a rough work. Then you can check that what thing is attached here. Is it carboxylic acid or it looks like aldehyde? And then you can do your oxidation, combustion, electrophilic or nucleophilic reaction. Don't try to attempt question with the skeletal formula directly. Now let's draw the skeletal formula. 1, 2, 3, 4, 5, 6. Okay. At second carbon, I have, okay, 1, 2, 3, 4, 5, 6. Let me make it a little bigger. Okay. 1, 2, 3, 4, 5, 6. Okay. First, you can draw the double bonding. I'm just changing the color so that you could see this one, and this one. You don't have to show number here. Yes. And then we have CH3. CH3 just like a carbon bonding. So you have to make a straight line, but you don't have to show any CH3 something. You have to draw a straight line here. No, there is no CH3 here. Sorry, there is no CH3 here. The another CH3 is at the third one. Okay. 1, 2, 3. CH3. Don't try to make like this. This one. This one is incorrect. Okay. Other one. What do we have? At second, we have chloro. You have to mention the functional group, but you don't have to mention methyl thing. That is a carbon thing. You don't have to show the carbon unless that is needed. For example, let me show you. I don't think so that they will give you any structure like this, but let me show you because this question can hit your mind also. See, if there is, you can say, for example, most of these students have missed, if there could be CH3, then the methyl group, if there is CH3, so this is the last carbon. If there is CH3, so students have missed, can we make like this? No. No, if this is CH3, so this will be your last carbon. This will be your last carbon. Now your chain will be having 7 carbon. You have to draw like this. Because if this CH3 is not present, so you can see the last one is CH3 actually. Are you getting my point?
Yes.
So this is how they can make your chain more difficult. If there, for example, let me make it more complicated. For example, if there is one more double bond, where there is a double bond between first and second, double bond. Simple. This is all about alkane. I can add OH here also, and I can add OH here and there. But actually, I'm not discussing OH with alkane right now, so that you should know, because alkanes are the simplest one, alkane and the haloalkane. So you should know that how we are making a structural formula, how we are making how we are giving name to the chain. That's what you should know initially, because alcohols, carboxylic acid, those things will make chain more complicated. Now let's move toward the alcohols. Okay. I'm just adding alcohol. I can add methyl again. I can add chlorine again. I'm just adding alcohol. This is how we can make chain more difficult after every step. Okay, this is, let's make more complicated chain so that we could add a lot of things. 1, 2, 3, 4, 5, 6. Hexane. For example, you have OH here. I don't think so that to make molecular formula will be difficult for you now. Let me show you. All these green bonds are hydrogen, for example. So what will be the molecular formula? C6, you can write all the hydrogen and you can write OH in the last. That will be the molecular formula. What will be the structural formula? The structural formula will be, let me show you. CH3, CH2, CH2, then CH2, then CH in bracket OH, then CH3. This will be your structural formula. Is it clear to you?
Yes.
Okay, let's move to the skeletal formula, because structure and a skeletal formula and the naming of the compound is actual thing. Okay, so let's name the compound. This is really easy. The name for the compound is 1, 2, 3, 4, 5, 6. And this is the first carbon. This is the second carbon. So this is hexanol. Okay, this is something like hexanol. Hexanol. But hexanol means there are 2 OH. So you have to mention it. 2 hexanol, but no. 2 hexanol means you have 2 hexanol chain. No, it will be hexane 2-ol. You should have a strong grip on this thing. This is hexane 2-ol. Hexane 2-ol.
I have a question.
Mm-hmm.
Do we always start naming from the right?
Yes. You can note down this rule, because there are a few conditions in which we are starting counting the number, counting the carbon from the left side, and this is when the functional group is very near from the left side. But students usually get confused in this thing, so it will be more better. You can follow this rule all the time, that you have to start giving number to the carbon from the right side all the time. But all are acceptable. It doesn't create any difference. In A levels also. Okay?
Yes.
Okay, so you can see if I am attaching OH here, so it is hexane 2-ol. But keep in your mind, if for example, if there is no any OH here, for example, let's forget about this OH. For example, if your OH is here, then you have to write one hexane 1-ol. Definitely. The name will be hexane 1-ol now. In this case, when OH is here, so you have to say, Miss, it should be hexane 1-ol. Or if in this case, if you say hexanol, that is also acceptable. That is also hexanol. If you are not mentioning any number for the ol thing, it could be at the corner carbon, at the first carbon, or the last carbon. So if it is, if you say, no, Miss, we have OH here at the left side. If you say, no, Miss, how would you know? OH could be here. So definitely I'll give this carbon as a 1. I'll say this carbon is the first carbon. It is still hexanol. So in case of this situation, which is on the screen, you can say hexanol, or hexane 1-ol is also acceptable. But if OH group is attached with the second carbon, third carbon, fourth carbon, so definitely you have to mention the number of the carbon. Now, I'll tell you about alcohols here in this topic, because most of the students ask me, Miss, does it make any difference if there is OH at the first carbon or OH at the second carbon or OH in the middle carbon, does it create any difference? Yes. It affects the reactivity of the chain sometime. Sometimes chain can become more stable just by changing the position of OH. I mean, this alcohol, na? We have different type of alcohols. Primary alcohols, tertiary alcohols, and other than this, we have secondary alcohols. We have 3 types of alcohol. Tertiary alcohols, I mean, they usually don't react easily because we have some other chapters like oxidation of alcohol, combustion of alcohol. So we have 3 types of alcohol. We have to select alcohol. In organic chemistry, there are reagents, and you can say we have to use different reagent when we are reacting any alcohol or anything with anything in the organic chemistry. We need some reagent, and you cannot select any reagent anytime. It depends. For example, if you say, Miss, whenever we react alcohol, we will select this reagent for the reaction. No, you have to check that which type of alcohol you have. And one more thing, the formation of alcohol is not that much easy in A levels. There are, I mean, if you say, Miss, for example, if you say, Miss, if you say, Miss, I have X and Y, and together they are giving me alcohol. So which type of alcohol? Primary, secondary, and tertiary. It all depends on the reactant. I mean, alcohol was so simple in O levels, but in A levels, this is much complicated. There are different types of alcohols. Let me show you the types of alcohol here, so that you should know why this is very important to give number to the carbon correctly. Wait, I just told you that we have 3 types of alcohol. Now see the structure. C, carbon, 1 more carbon, okay, and this is OH. This is OH. This is alcohol, okay? For example, there is 1 more alcohol. Let me change the color so that it could be clear on the screen. See, carbon, 1 more carbon, 1 more carbon, and this is OH. This is also alcohol. And let's add 1 more carbon here. Otherwise, you will say that there is a difference. See, propanol, second one is also propanol, 3 carbon. Okay. Wait, let me add 1 more carbon. Let me make it butanol, so that you won't raise a question, Miss, all are different. See, now 4 carbon, butanol, other one is also butanol. Now see the third one, the third one, 1 carbon, 2 carbon, 3 carbon, and the 4th carbon. And definitely this is CH3. And here we have OH. Now definitely you will say, Miss, this is the propanol. This is the propanol, because this CH3 is acting as a functional group, because when we are naming a compound, so we always have to take the longest chain. This is the longest chain. So this is actually, you can say this is the propanol. Okay. First 2 are the butanol, and the third one is propanol. Forget about propanol stuff. Just count the number of carbon. This chain has 4 carbon. This chain has 4 carbon. This chain has 4 carbon, and one alcoholic group. What is the dissimilarity here? Just position of OH? Just because of the position of OH, these 3 alcohols are having different name. And there's a difference in their stability. Definitely, if something is more stable, that will be unreactive. If something is less stable, that will be more reactive. So if I'm saying that the position of OH, which is attached here as a functional group, so the position of that OH is affecting the stability of the compound. It means that it's affecting the reactivity of the compound. Are you getting my point?
Yes.
Now see, the first one, you have to note down this point, because these things are very repeated in your past paper. The first one is primary alcohol. Okay, I'll tell you the difference. The second one is secondary alcohol. The third one is tertiary alcohol. if I'm not wrong. Yes, tertiary alcohol. Tertiary alcohol. This is the third one, the lower one. This is tertiary alcohol. So what is the difference? Just because of the position? Yes. What is primary alcohol? I mean, you don't have to say like this. Primary alcohol means OH is attached in the last. No. Primary alcohol means, I mean, why I'm calling it primary alcohol? Because OH is there in the last of the chain? No. Primary alcohol means the functional group of alcohol is attached with the carbon. You have to focus on the carbon, which is connected with alcoholic group. So in primary alcohol, alcoholic group is bounded with that carbon, which is bounded with two hydrogen. With two hydrogen. In secondary alcohol, the secondary alcohols are those alcohols in which alcohol group is bounded with the carbon, which is bounded to neighboring carbon and with one hydrogen only. I'll tell you about the stability. This is really easy if you can get the concept. Check the tertiary. Tertiary alcohols are those alcohols in which alcoholic group is bounded with that carbon, which is already bounded with three carbon, which is making single bond with three carbon, which is connected with three carbon. Are you getting my point?
Yes.
Now see what, I mean, why it is affecting the stability of this OH. Let me tell you, you know, carbon hydrogen bond is weaker as compared to carbon-carbon bond. I mean, in organic chemistry, this is really easy to break carbon hydrogen bond sometime, but this is not easy to break carbon-carbon bond. So you can see in primary alcohol, the carbon which is bounded with the OH group, in primary alcohol, the carbon which is bounded with the OH group, that is connected with two hydrogen and one carbon, that is least stable. Because the carbon which is bounded with the OH group is not that much stronger. It has one carbon at one side and two are oxygen. The secondary alcohol could be more stable as compared to the primary one, because here you have two neighboring carbon. I mean, carbon is supported by its own family. This is how you can memorize this thing. You know, organic chemistry is much tricky. So in primary carbon, carbon is supported by one family member. Let's just take it. In a second, carbon with which alcoholic group is bounded, that carbon is supported by two of its family member, and one will be hydrogen. And in next, the carbon, which is bounded with the alcoholic group, that is supported by its three family member, more stronger, tertiary alcohol, more stable. Is it clear to you?
Yeah, it's clear.
Okay, this is most important thing in your organic chemistry. Sometimes there are few reactions which are going to give you secondary carbon. Few reactions will give you tertiary alcohol, or the secondary alcohol, or the primary alcohol. And that is another difficult story. Okay, let's back to the topic. Okay. Hexane 2-ol. Okay, so we have to draw the structural formula. 1, 2, 3 carbon, 4 carbon, 5 carbon, 6 carbon. 1, 2, 3, 4, 5, 6. Yes. And here we have OH, but you have to show OH here. Hexane 2-ol. Okay. For example, let's add some things here. Okay. For example, there is chlorine. I will make chain little complicated, which is included in the syllabus only. I'm not adding more functional groups which are not included in the syllabus. Okay. So they can give you chlorine here. So second carbon. Okay. They can give you OH here. 1, 2, 3. This is fourth carbon. 1, 2, 3, 4. OH. What is this? This is chlorine. Okay. They can give you CH3 here. 1, 2, 3. Third carbon. 1, 2, 3. Third carbon. Oh, we don't have to write CH3 now. So there will be simple line only. For example, if they say that there is a double bond, if there is a double bond, so you have to remove this hydrogen definitely. Okay, so I'm making a double bond. So here is a double bond. Here is a double bond. This is the skeletal formula of the compound. Let me tell you one more thing here. Wait, I'll add that later. Let's name the chain because chain is getting complicated. 1 carbon, 2 carbon, 3 carbon, 4, 5, and 6 means this is hexane. Okay. You can note down the things before naming the chain. There is OH group at second and fourth. Okay, you can write like this: is second and fourth. We have all group. I'm writing like this. Okay. Then on third carbon, at third carbon, we have methyl. Okay. Other than this, at fifth carbon, we have chloro. Okay. Then 1, 2, 3, 4. Okay. Then 1, 2, 3, 4. At fourth carbon, we have ene thing. And what is the chain? Hexane. Now, I mean, it is going to be hexane 4-ene 2,4-ol. It could be like this. This is also, I mean, you can see these things in your syllabus also, but wait. Let me start from here. 3-methyl and 5-chloro. Chloro start from C. So, 5-chloro. Okay. Then we have 3-methyl. Okay. This is 1, 2, 3, 4, 5, 6 hexene. Hexa 4-ene. Okay, what about alcoholic group? I mean, one thing is still there, which is remaining, and we have to mention that thing here. See, we haven't mentioned this 2,4-ol. Now you have two options for the alcohol. I could tell you all the suffix and the prefix in the starting of the class, then you have to do the learning. It would be more difficult for you. Now see, for the alcohol, I mean, you have two options. Either you could use suffix or prefix. For the alcohol, we have a suffix, which is ol. You can say hexa 4-ene 2,4-ol. You can do like this. Or other option is you can use prefix for the alcohol. I mean, you don't have to write all in the start. There is another word as a prefix. I mean, there's another term as a prefix for alcohol. For the alcohol, do you know the prefix for the alcohol? Let me tell you here. You can note down this point. The suffix of the alcohol, you already know about the suffix. The suffix is ol. And what about prefix? The prefix for the alcohol is alcohol, OH, hydroxy. If you're unable to use ol sometime, if you are unable to understand that where to use ol or something, and if you're getting confused, you can move toward prefix. You can say that this is 2,4 hydroxy. 2,4-hydroxy 5-chloro 3-methyl hexaphorine. You can see. Sometimes we have to use prefix. It depends. Or you can do like this: hexa 2,4-ol 4-ene. That is also good. But this is more good. You can see. I mean, we have option of using prefix. It's up to you. Sometimes the chain could be complicated, and if you're unable to use suffix at that time, you can move toward the prefix. You can see we have a prefix of alcohol. You can note it down. Alcohol, OH group, hydroxy. So 2,4-hydroxy 5-chloro 3-methyl hexaphorine. This is the name of this chain. Is there any confusion?
No, it's clear to me.
Okay. Let's move to. Okay, then alcohol are easy. Oh, yes. I wanted to tell you one more thing, then we can move to another functional group. Let me tell you one more thing. See, 1 carbon, 2 carbon, 3 carbon, 4th carbon. If OH group is here, so see the Skazal formula 1, 2, 3, 4. So you can say This is OH. You have to mention OH. Okay. But what if OH group is here? Now, are you going to give like this? No, this is not acceptable. What you have to do, wait, let me show you one thing. I'm making dots for the carbon. This is one carbon now. This is second carbon. Because if you are writing OH here, what does it mean? It means this is O, this is not carbon. That's why I have made separate bond for the OH. See, another bond, OH. What does it mean? Means this corner is a lone carbon. This corner is carbon. This corner is carbon. Now there is OH at the last carbon. So you have to show OH separately. So if you cannot do like this, no. What you have to do? See now. You have to bring it down. And you have to mention OH here. What does it mean? It means this point is for the OH. There is no carbon. So the last carbon was here. Because you have mentioned OH here. So it means this bond is for the OH. And this is the last carbon, which is the fourth carbon. Is it clear to you?
Yes.
And what is this? This is butanol. So you can say that 1,3-hydroxybutanol, 1,3-hydroxybutanol, or you can say butane 1,3-ol. Because now you know the prefix also. I'm telling you the prefix because most of the time they are using prefix in the exam. And sometimes you have to use prefixes when you are unable to name the carbon chain. Don't get confused. If you feel that there could be mistake, you can go for the prefix. We have prefix available for every functional group. So this is all about alcohol, alkane, and alkene. And the next thing will be carboxylic acid and the aldehyde and the ketones. And one more, esters and ethers. That's what we have to discuss after this whole step. Okay, so give me a minute.